All right, the degree. They're asking for the identify the degree, the leading term, and the leading coefficient. So we have to start with the degree, and that is the largest exponent in the polynomial. So the largest exponent. So if looking at this first one, the largest exponent we see, 423, would be a 4. Remember, these are the exponents, the raised letters on your variables. So it's a 4. Now the leading term, you're looking at the one with the degree, okay? The highest degree. So that was with the exponent of 4, so that is the term negative 4x to the 4th. Make sure you include the negative and the exponent variable coefficient. Leading coefficient of that term is negative 4. Then the next one, the degree is a 7, because right here you see this 7. The term is a positive 7x to the 7th, and the coefficient, leading coefficient, is a 7. And they want you to recognize this because when we go to factor, you want the largest term first, the one with the highest degree. So now we have 19, 21, and 17. Well, 21's larger, so we have a degree of 21. That term is negative 14x to the 21st, and then the coefficient on that is negative 14. And when you're doing this, when you click in the answer blank, a menu will pop up. Make sure you choose the one that has, when you're writing the exponents, it'll have a little X and a raised box. Even if your variable is some other letter, like a Y, still choose that X with the raised box, because that raised box is where you'll put that 4, 7, and 21. We're going to evaluate the polynomial by replacing the x with negative 2. So we have negative 3 halves times x cubed. Well, that would be negative 2 cubed. Then negative 6 times x squared. X is now negative 2 squared. Minus 3 times x, which is negative 2. Now, remember, order of operations, you do what's in parentheses first. Well, parentheses means when there's an action in there to do, like in the parentheses is 5 plus 2. These parentheses, there's just one number, so there's nothing there to do. So the next thing is to do exponents, and that's what we're going to do next. So this is negative 3 halves times what we get when we cube a negative 2. Now, over here I wrote some rules. When the base is negative, and that's what we have, a negative 2 is our base, and the exponent is odd, then you don't have to worry about your sign. It's going to be negative. So that's going to be a negative, and then all I have to do is multiply 2 times 2, which is 4, times 2, which is 8. Now, negative 2 cubed means negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. But you don't want to have to do that because, for example, what if you had negative 1 to the 200th power? Well, you don't want to multiply and see what you're going to end up with, negative, positive, negative. You want to know, okay, if base is negative and the exponent's odd, I'm going to end up with a negative number. If the base is negative and the exponent is even, I'm going to end up with a positive number. So if the exponent was 200, I'd end up with a positive. All right, let's keep going. So this is negative 6 and negative 2 squared. The base is negative, but the exponent's even, so we know we're going to have a positive, and that's going to be a 4, because negative 2 times negative 2 is positive 4. And then let's just go ahead and multiply. Negative 3 times negative 2 gives us a positive 6. We'll put that on the end. That won't affect anything if we do that now. Now, right here on this first one, I have a fraction. So I'm going to put this negative 8 over 1. I'm going to make it a fraction. That way I can cancel any numerators and denominators and then multiply across. So right here, 2 will go into 2 once, and 2 goes into this 8 4 times. So I was able to get rid of my fraction by canceling. And you could multiply across and then reduce, but to me that's more work. All right, be careful with our signs. Negative times negative is going to be a positive, and that's 3 times 4, so that's a positive 12 here. Then negative 6 times 4 right here, that's going to be a negative 24. Notice the number, negative 6 and the 4 are right beside each other, so that means multiply. And then we're going to bring down our plus 6. And this was a 24. So now we have add and subtract because we have number, sign, number. When there's parentheses, we're multiplying, but when there's just sign, number, sign, we're adding and subtracting. So right here, signs are different. Subtract, take the sign of the largest. That would be negative 12. Negative 12. Whoops. So, here we go. 12 minus 24 will give us negative 12. Then bring down the plus 6. Signs are different. Subtract, take the sign of the larger, and that will give us a negative 6. So our answer is negative 6. This one we're replacing the x with a negative 1. You might want to stop it, pause it, and plug in and see if we come up with the same thing. So go ahead and pause it. All right, so you've had some time. We're going to replace the x with negative 1. So now this negative is part of our problem, but then the x is negative 1. Then plus 2 times the x, which is negative 1 squared, minus 4 times the x, which is negative 1 cubed, plus 5 times the x, which is negative 1 raised to the 4th power. So right here, I can go ahead and do this because it's not going to affect anything. Negative times negative 1 is 1. Plus 2, I want to do my exponents. So now, the order of operations is parentheses, exponents. Parentheses means when there's an action to do inside the parentheses, like 4 plus 5 in the parentheses. These are all just numbers inside the parentheses, so we go to exponents. So this is 2 times what I get, negative 1 squared. Base is negative, exponent's even. 1 times 1 is 1, so positive 1. Then negative 4 times negative 1 cubed. It's going to give me a negative 1. Plus 5 times negative 1 to an even power is going to be positive 1. Now the 1s was easy because 1 times 1 is just 1. If it had been like negative 2, then we'd have had to do a little bit more work. All right, now we're going to multiply to get rid of things. So bring down the 1 right here. 2 times 1 is 2. Right here, negative 4 times negative 1 is plus 4. Bring down our plus 5. And then right here, 5 times 1 is plus 5. So it's addition. Doesn't matter what order you add it in, or add it in the order that's easiest for you. I see 5, 10, 15, 17. So our answer is 17. We are adding polynomials. Remember, you add like polynomials, like terms, so they have to have the same variable with the same exponent. It doesn't matter what the coefficient is. It's the variable and the exponent. So when we look right here, this 43x to the 5th and this 16x to the 5th, those are like terms. Now here's a thing, this is a plus, so this tells us to add, and it doesn't change the signs. So when we have a subtraction, I think we have one that's a subtraction, that will change all the signs after it. But if you were to multiply a plus times everything in here, you're still going to get the same sign. You're going to get a positive 16x to the 5th, a negative 67, negative 61. So you don't have to, when it's a positive, you don't have to worry about multiplying it throughout. Just collect your like terms. So I am adding, let's just do this as a column. That might make it easier for you to see. If you can do it in your head, that's great. If not, here's a column way to do it. We're going to line them up. So I have a positive 16x to the 5th. I want to make sure that I put it in the x to the 5th column. Then I have a negative 67x cubed. So I want to make sure that I put negative 67x cubed in the column with the x cubed. And then I have the constant term of minus 61. So I put it in the constant term column. So now I'm going to combine these columns. Now remember, when you add and subtract, you just add and subtract the coefficients and you rewrite the variable and exponent. So 43 plus 69 is 59. Rewrite x to the 5th. Now when you multiply and divide, the exponent changes, but when you add and subtract, it doesn't. So right here, negative 37x cubed minus 67x cubed, signs are alike. So we add and keep the common sign, so that's a negative. And that's 104x cubed, keep the x cubed. Double check our math, 14 carry the ones, 104. The last term, the signs are different. They're both constant terms, they don't have a variable on them. Signs are different, so we subtract, take the sign of the larger, so we know it's going to be a negative. And if we take 61 away from 3, well, if we take 1, that's 60, and 2 gives us 58. So that is our answer, 59x to the 5th minus 104x cubed minus 58. Be careful with your signs and your exponents. Here's a problem where we're finding the difference, so we're subtracting. That is a big issue because this negative changes everything after it, not before it. So this is really not a negative 15x squared, it's going to be a positive 15x squared. Because this right here is understood to be a negative 1, so negative 1 times negative 15x squared gives us positive 15x squared. Negative 1 times positive 38 gives us negative 38. So I like to do that first so that I don't make a mistake, and then I kind of mark it out so I don't go back to it. I know to go back to these numbers. So I have 25x squared. I'm going to line them up again. You don't have to, but I want you to see when you don't have a term what to do. So 15x squared, that goes under this column, the x squared column. So plus 15x squared. I'm going to add up that column. I don't have an x term, so my negative 38 is going to go over here under my negative 66 because those are both constant terms. So adding 25 plus 15, that's going to give me 40, and rewrite the x squared. This had nothing to go with it, so I just bring it down, negative 40x. Right here, negative 66 and negative 38, signs are alike. We add, take the common sign. So that's going to be negative, let's see, 8 and 6 is 14, carry the 1, 104. So there is our answer.